While you are completing your tea, I'll just introduce the speaker. Professor Michel Danino. I've known him very well over perhaps 2 decades. He has been a very serious scholar of all aspects of Indian civilization. He has written several well-known scholarly books and some popular works also. Indian Culture and India's Future, The Lost River on the Trail of Saraswati, and his volume on Dawn of Indian Civilization and Elusive Aryans. It is being promised for quite a few times, and I am sure he will be bringing it out during this year, hopefully. He has been working on Indian culture, Indian history, the scientific and material traditions of India, and he is perhaps like a one-man army trying to popularize whatever the scholars have found, including himself, to a very large number of audience. He has made many of our IITs familiar, because this subject was totally anathema or taboo in these institutions. He could carefully and cleverly introduce courses, series of lectures in Roorkee, in Kanpur, IIT Bombay, and now currently has been associated with a new Center for Archaeology in the Indian Institute of Technology at Gandhinagar, where he is building a group working on all aspects of ancient India, including Indian sciences. He has been a member of Indian Council of Historical Research. He has been a member of the Indian National Commission for History of Science, constituted by the Indian National Science Academy. It's a pleasure to invite Danino ji to give his talk today, 45 minutes to 1 hour.
Thank you so much, Dr. Srinivasji, and my gratitude to Dr. Sinarindi Das, Dr. Mamata Das, and Professor M.S. Sriram for having me here today. I've been visiting this foundation for some years, not often enough, but I must say that I had the technology is always problematic. I would like to start with a small personal reminiscence of having visited Professor K.V. Sharma several times, at least twice, if not thrice, in the Gandhinagar flat. And I remember how he took me around proudly around his library, which is now here. And in the last visit, he was sitting on a stool with some scooter tires piled over the stool so that he would not have to sit up. He was literally sitting up all the time. And till the last, he was working so hard, quite an inspiration. A small anecdote also I would like to say, because even though I'm not a scholar, I have visited many collections of manuscripts across India out of sheer interest, starting with the epigraphic wing of the Archaeological Survey of India. and Mysore Oriental Institute, and several others. And I have had very similar experiences as Dr. Dashri, except once. And that once was very recently when we took Professor R.N. Iyengar, who was visiting us at IIT Gandhinagar, to the Sri Mahavir Jain Aradhana Kendra in Koba, which is a suburb of Ahmedabad. And they have 2.5 lakhs of manuscripts, properly catalogued. They have a team of pundits because it's a very well funded, Jain institutions are often much better funded. They have a resident team of pundits, and whatever catalogs they have, whatever manuscripts they have catalogued and scanned, they make available freely, even over email. You can just ask them and they will mail the PDF. They have a Facebook page, they have a WhatsApp group and whatnot. I was very, very surprised to see such a warm, forthcoming institution. And this is 2.5 lakh manuscripts. Supposedly, according to Dominique Vujastik, it might be the largest collection in India, but nobody knows, in fact. So this is at least one small positive note in an ocean of challenging situations. The talk that I had proposed to Professor Sriram is nothing essentially new, but a kind of a quick panorama of India's contributions to other cultures in the field of science. It actually forms part, this is an expanded version of a simpler lecture which forms part of the course which I'm offering in IIT Gandhinagar on an introduction to the history of science and technology in ancient India. And I'm proud that there is one such course. There are a few more. IIT Kharagpur recently, with the impulsion of Professor Ramasubramaniam, has initiated and is still holding a full semester course completely taught by its own faculty. So there are such small attempts across India, but it is to be regretted that we do not have any, apart from the cell that Professor Ramasubramaniam directs at IIT Bombay, we do not have a single department in any Indian university teaching history of Indian science and technology on a regular basis. So this is unfortunate. So let me simply review what a few, and I will also include a few controversies in the sense of unresolved debates deliberately. Of course, the West's acquaintance with Indian science and technology starts with the beginnings of the colonial age, with a few stray exceptions before, and it starts on a very romantic note. This romantic note is struck here by Voltaire, who is somehow convinced that all science emerges out of India, which of course is not quite the case. But he was also convinced that Pythagoras had come to India to learn mathematics, which incidentally is not an Indian tradition, but a Greek tradition, a late Greek tradition. So this is a romantic view of India as the source of all knowledge, which to some extent is reflected still in the 20th century by Will Durant, who sees India as the motherland of, again, almost all significant knowledge, much of our mathematics, ideals of philosophy, religion, self-government, etc. So, of course, there were other views. And the colonial scholarship, which developed in the 19th century, especially late 18th century onward, had a number of different voices. And at the other extreme was the voice of Macaulay, who considered that essentially Indian civilization had no knowledge to offer. And its culture was based on false history. He's referring to the Puranic cycles, false astronomy, false medicine, that is the Ayurvedic system, in company with the false religion. So this, of course, is extremely clear and straightforward. But there were other views, like, for example, when certain astronomical debates were initiated, and I will allude to one of them later, we had a number of scholars assuming that Indians were basically not capable of having made accurate astronomical observations. This is the famous debate of the pole star. Recently, Professor Iyengar brought out a beautiful paper on Dhruva and the pole star. And, but this was debated right in the 19th century by people like Jacobi, the German scholar, Keith, Whitney, and others. And the British scholars were of the view that Indians could not have accurately observed the pole star. And the ritual of the husband showing the young wife, new wife, the pole star as a symbol of fixity, steadfastness, and so on, should not have been taken literally. It might have been just about any star vaguely in the northern sector. So we have these deprecating views, but then let us try to look at some of the evidence that today we know is very reliable. And we can start in the proto-historic period. Of course, there the evidence is very, very scanty. Nevertheless, I found that this could be interesting to be mentioned. You might know that the Harappans Indus civilization, also called Harappan, Indus-Saraswati civilization, were great traders, and they were technicians. They were extremely good at certain technologies, especially of ornament making. But in the context of trade, they created a certain system of weights which was standardized all across the civilization, which means from what is today Pakistan, even Balochistan, all the way to almost Uttar Pradesh, Gujarat, parts of Maharashtra, and so on. And this system had a double series. One started from the smallest weight, which you see there, extreme left. This is all made of stone. It's a very hard stone called chert. And the smallest weight was 0.86 or 0.85 grams, it depends. And then you had for a while the weights following in simple geometrical series. But for some reason which is not very clear, they switched over for the next weights all the way to about 13,000 times the initial weight, so that's a weight of more than 10, 11 kilos. They switched over to multiple of 10 times, 100 times, even 1,000 times the initial weights. The reason has been debated, but it's not very, very clear. However, what I wish to mention here is that the Harappans were trading with, yes. They were trading with Central Asia, they were trading with Iran, they were trading with this entire region of the Persian or Arabian Gulf. Where several Bronze Age civilizations existed. This is Mesopotamia, the famous Mesopotamia, what is today Iraq and parts of Syria. And then you have a civilization known as Dilmun in what is today the Emirates, basically. Magan corresponds roughly to Oman, and so on. And a lot of Harappan artifacts, especially jewels, pots, pottery, were found, and a few seals also, the famous still undeciphered Harappan seals, were found across all this region. But what is extremely interesting is that in Dilmun, there was a certain sets of weights which were used in the trade, which was known in the Mesopotamian tablets as the standard of Dilmun. But it was shown in the 1990s by this German scholar Vogt that these were actually the Harappan weights. So the Harappans had exported their system, and it was adopted in this region. So perhaps this is one of the first scientific exports from the Indian subcontinent. I thought it was worth a mention. We jump now into the historical phase, 2,000 years later, and there are, of course, a lot of interactions. Historically, they are very well known. We know that there are Indian soldiers serving as mercenaries in the Persian army, and the Persian army was sometimes fighting wars in Greece, and therefore there were already contacts. We know that these contacts were understood in India to some extent. Panini is one of the first to mention this word Yavana, which in some contexts means Greek, in other contexts can mean Roman, and in general contexts can mean a Westerner, somebody from the West. So these are found in many texts later on. Alexander's campaign was a massive interface between the Mediterranean world and India. And then there were other, following this, there were other interactions such as Megasthenes' presence in India, and then many texts which were written by the Greek. Ashoka, on the other hand, boasts that to teach dharma or dhamma in Pali, he is sending emissaries across much of the known world of his days. And in this edict, the famous Rock Edict 13, he boasts that he's sending emissaries all the way to Antiochus, to Ptolemy, and all these Greek kings, and even Alexandria. Apart from South India itself, the Cholas, Pandyas, who were not part of his empire. So therefore there are contacts, and perhaps this very, very brief background explains a certain number of concepts which begin to travel. And I should say, before I go into the details, that very often it is not at all evident, not at all easy to decide in which directions ideas travel, because directions may travel from one to another. They may travel from a third point to point A and B. Sometimes they may also emerge independently. So this is the case, for example, of the concept of nakshatra. You know that the Indian system had a lunar zodiac, not the solar zodiac actually will come much later. And the lunar zodiac had 27 or 28 nakshatras, and which can be technically called lunar mansions. But it so happens that the Chinese and later the Arabs had also such a system. So, of course, initially the colonial scholars assumed that Indians had learned this system from the Chinese, but in fact there is no final conclusive argument one way or the other. There's been a lot of debate, but this is at least one concept which is common and which may have also emerged independently. One concept which probably India borrowed from Mesopotamia is the hour of 60 minutes, and it comes a little late in Indian astronomical and astrological reckonings, because the initial Indian units are either the Ghatika of 24 minutes or the Muhurta of 48 minutes, and then there are larger units also of the day. But the concept of 24 hours of 60 minutes was not not present in the original Indian literature. So we may accept it as being of Mesopotamian origin. Similarly, for the week of 7 days, although some Indian scholars have disagreed. For example, P.V. Kane produced some evidence that there was such a concept in ancient India, but it has not been widely accepted, I believe. And then, and this is the kind of controversies that we should be researching more deeply, and I hope some of our young scholars will contribute to these discussions, because they are going on. The concept of the 12 Rashis, the solar zodiac, not the lunar zodiac anymore, which appears in India in a text called Yavana Jataka, which according to Pingree was written in the 3rd century. David Pingree, the famous American scholar who spent a good part of his life studying India's astronomical texts. And he had an idea that this was actually a translation of a Greek work. But recently, Bill Mack has disagreed and considers that this is an original attempt by the Indianized Greeks to fuse together Greek and Indian astronomical and astrological concepts. So this has reopened Pingree's work, and actually Pingree's assertions on Indian astronomy have often been controversial and often been challenged, and but that doesn't detract from the huge amount of work that he did for the Jyotisha traditions, as he called them, and the massive catalogues of manuscripts dedicated to astronomy that he published. That was a stupendous work in itself. But it is a fact that there is some cross-current going on at the level of astronomy, because Varahamihira in his Pancha Siddhantika himself mentions two Siddhantas, the Romaka and the Polisha, which are obviously imports, but it looks as if their calculation methods were not eventually adopted by Indian astronomers. So this is a field that would require more research, and the big question is basically how much did Indian astronomers learn from Greek astronomy? And the answer again is not very clear. There are certain concepts which possibly were imported. I will mention the concept of epicycles in particular. You know that when you have a geocentric reference or theory to explain the retrograde movement of certain planets, you need to assume that their orbits are not circular, but there are circles on the circular orbits which they follow. These are known as epicycles. And definitely the Greeks had such a theory, and it appears in Indian astronomical texts too. However, so therefore the assumption was that the Indians had learnt it from the Greeks. But there is no final answer again, because the procedures which Indian followed were substantially different and sometimes yielded better results than the Greek texts themselves. P.C. Sengupta in 1931 was one of the first who attempted a comparison of the two methods, and his opinion was that Hindu astronomy in its scientific form, although of a later date than Ptolemy, is original and not borrowed from a foreign source. There is evidence that some crude form of Greek astronomy was transmitted to India and went by the name of Romakan Purisha Siddhanta prior to the name of Aryabhatta. But our great Indian astronomers Aryabhatta with his pupils Varamihira and Brahmagupta had to construct a new science altogether. So I believe that this is a field which is not exhausted, and Eric Forbes, a British scholar in the 1970s, who was very much convinced that Indians had borrowed a good deal from the Greeks, nevertheless had the honesty to record that the Indian double epicycle theory, governed though it was by divine agencies pulling the celestial bodies with invisible strings of air, nevertheless yielded better predictions than the Greek kinematical model, which had to satisfy the philosophical requirement of being ultimately analyzable in two components of uniform circular motion. So here he brings out the difference between the two. Now, there is a problem when we come to the first text of geometry. And as you know, they are the Shuba Sutras. The Shuba Sutras are texts, 4 of them have survived, but there are fragments of a few more, which are datable usually to 400 to 800 BC. The date is contested because there is no final evidence. And these are manuals of constructions of brick altars for fire rituals. They are extremely detailed. All these altars usually have 5 layers of bricks. Each layer has to be made of different shapes of bricks. They are not allowed to be repeated identically. And what is striking is that the surface area of these altars is imposed. It is not allowed to vary. But the shape can vary. So they may be circular, they may be square, they may have the form of a tortoise, of a falcon, they may be triangular, and so on. So, of course, if you're going to vary the shape without changing the surface area, this is going to lead to very intricate calculations. So the Shuba Sutras are about all these calculations and the transformation, for example, of a square into a rectangle or into a triangle or approximately into a circle, and so on and so forth. So a lot of procedures, geometrical procedures, having a ritual origin. And this is precisely what Seidenberg, the American historian of mathematics, who started his work in the 1960s, what exactly he studied. And he went very deep into, so there are 2 famous papers by Seidenberg. They are available, of course. First of all, he complained that the great historians of science like Neugebauer and van der Waerden, who had written extensively on history of mathematics and astronomy, had completely neglected the Shuba Sutras in the history of mathematics and did not consider it important. And so I will not read out this fully to save some time, but he says that it is true that those who maintain the priority of Indian geometry may have claimed too much when they said that Greek geometry came from India. What they should have said was that Indian geometry and Greek geometry derive from a common source. And then he elaborated, and I think his view is important. He writes that Greek geometry, and he's basically comparing the methods of Greek geometry versus the Indian geometry reflected in the Shuba Sutras, contains many aspects that can be explained on the assumption that it derives from ritual of the kind we find with the Indians. Whether Greek geometry derives from the Indian geometric ritual or from a different system, very much like it is not essential to decide. But basically his view was that the original system from which possibly both the Shuba Sutra and the Greek systems might have derived was closer to the Shuba Sutra way of doing geometry. And he said, we do not hesitate to place the Vedic altar rituals, or more exactly, rituals exactly like them, far back of 1700 BC, when Babylonian mathematics was taking shape. The elements of ancient geometry found in Egypt and Babylonia stem from a ritual system of the kind described in the Shuba Sutras. And he stopped there. He didn't want to assert that the Shuba Sutras themselves were the origin of it, because he was not getting such ancient dates from the Sanskrit scholars. In fact, at some point he argued, and this is an argument which is missed by many scholars, that the date of the text of the Shuba Sutras was not important. It might be a late text, it might be 300 BC, 400 BC, it didn't matter. He said what matters is the date of the tradition that it embodies, and not the text itself. And this tradition, he was able to, and this part is very, I believe, uncontroversial, to trace it to the Brahmanas. The Brahmanas, as you know, already have explicit a lot of rituals, and some of them have to do with construction of altars. And he showed that the Shuba Sutras are not to be taken as a beginning, but rather as a culmination of a long tradition. So this is again a debate which remains open-ended. We have the famous case, and I will not spend time on it, of the transmission of the Indian numeral system, the place value system of numeral notation. It is so famous, and so many scholars have spoken about it, that I will not spend time, except to say that we have evidence of transmission of this system out of India pretty early on. And I will show just two pieces in my talk. One is this one by the Syrian bishop Severus Sebokht, who writes in the 7th century, when still in India there are very, very few inscriptions exemplifying this system. There are a few, but most of them actually are later. And this Severus Sebokht says, the science of the Indians, their subtle discoveries in astronomy, discoveries that are more ingenious than those of the Greeks and Babylonians, and their valuable methods of calculation with surpassed description done by means of 9 signs. So obviously he's forgotten the 0, because it should be 10 signs. But you cannot do these calculations if the 0 is not integrated. So this is one famous piece of evidence. About the same time, or a little earlier, we have another debate going on regarding the first Siddhanta text, or the first classical text of Indian mathematics and astronomy, the famous Aryabhatta. And there is a controversy, because Aryabhatta gives a table of planetary positions. And a number of scholars, including David Pingree again, had argued that these tables were actually copied from Greek or Babylonian tables, and they were not based on original observations by Indian astronomers. So one French scholar, Roger Billard, in 1971, took up this question, and he made what is basically an elaborate statistical study. I will not go into the details, and my memory is not also so fresh, but you can see that these are statistical deviations from the values in the between the tables of Aryabhatta and the actual values that modern astronomy would be able to calculate. And there you see that this is a line of zero deviation, and these are the various planets. Now, leaving apart Mercury, because Mercury is always very difficult to observe being so close to the sun, he found that Aryabhatta's observations for all the other planets, of course visible to the naked eye, had close to zero deviation at a date approximately 510 AD. And Aryabhatta does tell us that in 499, he doesn't put it quite that way, but 499 AD, he is 23 years of age. He doesn't say exactly that he has written at the age of 23. He doesn't say, but he says that this is, so 510 is perfectly possible equally. And so what Bia's conclusion was that these deviations being close to zero at the time of Aryabhatta must have the observations, the values in the tables must have been based on actual observations, and they were not borrowed, because had they been borrowed, then they would have been, at this particular date, there would have been major errors, major deviations. So, of course, his whole book is far more elaborate than this. It's just a summary. David Pingree offered a rejoinder, fairly bitter rejoinder, in fact, and tried to find fault with this method. Van der Werden came as a kind of referee between the two and published a famous paper some 10 years later or 15 years later, where he compared both arguments, and his decision was in favor of Roger Bia. So in any case, and this was actually in his book in French, Roger Bia says, we must not fail to notice the astonishing precision of those sets of mean positions during the period of observations. Such precision was certainly the very best that could be obtained through the method of ancient astronomy, its instruments and its mathematical methods. In other words, despite his speculations on yugas, he's referring to the yuga system of Indian astronomy, which he finds very fanciful and a kind of drag on the progress of Indian astronomy. Well, this is another possible debate. I am not going to it. Aryabhatta is certainly one of the great figures of the history of astronomy. There would be much to say on the question of medicine, and I think this is another area. My watch has stopped, so you should tell me 10 minutes, 20 more minutes. Okay. Otherwise, I could go on. No. Very well. So, and as you will see, I am using a number of French scholars. Well, so happens that I have read them, so and they are not always accessible in French translation, so I'm fond of using them. And they are all very serious scholars, especially the French Indologist Jean Filiosa, who did a lot of work in many areas of Indian Indology. He was a prodigious Sanskritist, and he was a medical doctor by initial formation. He was a doctor, physician. And he did some work on the fact that there are concepts common to Greek medicine and Indian medicine, especially the three humors of Greek medicine and the three dosha of the Ayurveda system. So his paper is quite objective. He's simply trying to look into the possible dates. He finds that Plato in his Timaeus mentions this theory, but then Plato, according to Filiosa, comes definitely much later than the Ayurvedic, the beginnings at least of the Ayurvedic tradition. So his view, and his paper is worth studying, is that as scientific intercourses during the Persian domination of Greek and Asian countries and a part of India would have been easy, an influence of the Ayurvedic theory on those prescribed by Plato is quite probable. So please note the word probable. Again, it's very difficult to reach definite conclusions in these fields. Eventually, you need some hard evidence of actual transmission. Otherwise, you can simply build the likeliest theory. And again, it doesn't mean that the transmission has to be directly from India to Greece. It could be through some intermediaries like Persia, for example. There are several, this is a much less controversial statement. Direct references in the Hippocratic collection to the borrowing of some Indian drugs and medical formulas in Greece. In the period of the expansion of India towards Central Asia and China and towards Indochina and Indonesia beyond the seas, Indian Ayurvedic medicine was one of the main matters of export, along with astronomy, religions, and the arts. And in fact, we have later evidence in the classical period of transmission of Indian medicine. This also is not controversial. It's well known that there are manuscripts of medicine, like the Weber manuscripts, which were found in Central Asia and in Sanskrit or in translations. So this is well known. Even the Japanese imperial treasury is on record for having Indian drugs and the Indian names preserved. So therefore the spread was quite wide. Sushruta's name occurs in inscriptions in Cambodia along with lists of medicines under Jayavarman VII. And Tibetan medicine, of course, which is not surprising, this is next door, is closely related to Ayurveda. A quick word on the interactions with China. They are reasonably well known. There have been a few debates also, but nothing very controversial. It's well known that in the 7th and 8th century, there were Chinese mathematicians, Yixing is one of them, who refer to Indian mathematical texts. R.C. Gupta, whom Professor M.S. Sriram mentioned in the inaugural session, wrote that by the end of the 7th century CE, much of Indian mathematics and mathematical astronomy was known in China. The compilation of the Qiu Qi Li in Chinese by Gautama Siddha, we will see who is this Gautama Siddha in a minute, from Sanskrit sources represents the culmination of such transmission in 718. In fact, Gautama Siddha was a member of 3 families of Indian scholars who settled in China, certainly at the invitation of the Tang dynasty. And Gautama Siddha wrote a 120-chapter book in which he discussed Chinese and Indian mathematical and astronomical systems. And in this book, he very early on explained the Indian decimal notation, elements of Indian trigonometry, etc. So here the direction of the translation is quite clear. Chinese texts of alchemy and metallurgy often also make reference to Indian texts in the same field. And this is not very surprising because we do know that the Chinese were very avid importers of Indian manuscripts. In fact, all of their pilgrims to India would go back loaded with manuscripts, and sometimes they cataloged them and they worked hard at translating them. So this is all well established. So therefore, I will skip this quotation to save time, but this has been recorded by a number of sinologists like Jean-Claude Matzloff, the Chinese borrowings in Indian mathematics. But please note, and this is the work of Vijaya Deshpande, who has been actually trying to translate some Chinese texts back into Indian languages, that there are also medical works from the 5th century AD onward, which includes materials brought by the Buddhists and connected to Ayurveda. There are also texts of ophthalmology, which are basically based on Ayurvedic ophthalmology in China. So this is an interesting field. Southeast Asia, there's quite a lot, and it's well known. The numeral systems of the scripts in this entire region are borrowed from India. The Surya Siddhanta was quite popular in the region. And we find in Cambodia this inscription, famous inscription, which was actually from the late 19th century. It was discovered in the late 19th century, but published by Kurdes, the great scholar of Cambodia, in 1931. And here you see 3 digits which read 6, 0, and 5, which is equivalent to 683 in the Gregorian calendar. And this is said to be the first inscription in the world where the zero appears. It is not necessarily quite correct. Indian epigraphists have proposed a few more such inscriptions in India, but they are not universally accepted. Recently, one scholar, Meera Nanda, tried to argue that this was proof that the zero did not originate in India, but originated in China, and from China migrated to Cambodia. The whole argument is very strange, because not only we have Severus, the bishop, Syrian bishop, telling us about the same time, just 10 or 20 years earlier, that the Indian system has reached the Mediterranean world, but we have definite, conclusive mathematical proof from the text of from the Aryabhatta that Aryabhatta must have known the decimal system and the zero, though he doesn't talk about it, because some of the algorithms that he gives, for example, the extraction of square and cube roots, are absolutely impossible without the complete decimal system with the zero. So therefore, and there is further textual evidence in addition from the 3rd century and so on. So therefore, it is quite clear.
Sorry to interrupt. Is it to be read from right to left or left to right?
This is to be left from left to right.
Left to right?
Yes. So this is 6, 0, and 3. Yes. I'm sorry, 5. Yes. So there cannot be really a controversy here. This is clearly an import from India. I will conclude with the Arab world, and I'll just take 5 minutes, where there is a lot going on, and this is so well known that I will just skim over the evidence. We have, of course, a lot of scholars traveling to India and recording their exchanges, their discoveries of Indian sciences. But there is a major development, which is the House of Wisdom created by Caliph Al-Mansur in the 8th century and 9th century AD, where this is sometimes called the Golden Age of Islam. And the concern was to discover as many manuscripts as possible from other cultures, especially the Greek culture and the Indian culture, and translate them into either Arabic or Persian. And these were texts of philosophy, texts of medicine, texts of mathematics and astronomy. And this is where, in fact, 2 Indian scholars are even named in the Arab text as being there in this. It's a kind of a translation bureau for all purposes. And Charaka Samhita was one of them. Sushruta Samhita also was translated. And well, there are, of course, legends about the Caliph being cured by an Ayurvedic medicine. This is the picture of Caliph Harun al-Rashid, and this is a painting showing all the scholars gathered in this House of Wisdom. It is even said that the translators were paid the weight of the manuscript in gold. So among them, and this is the last point I will make, is AlKhawarizmi, the famous Central Asian originally scholar who, in addition, before I go to him, there is also mention, this is very interesting, of 2 Indian astronomers who have been invited to Baghdad to create observatories in Baghdad and Damascus. Now, if they were invited from India to do so, it does show, confirms that the Indian astronomical tradition was highly regarded. Otherwise, they would not have been called to create such observatories. It's regrettable that in India, no such observatory of this period has ever been found. There are, of course, chapters in the Siddhantas about how to build observational instruments. In fact, I believe Professor Sriram is working on this aspect quite deeply, but no actual relic of an observatory has ever been found. So, concluding with AlKhawarizmi and the importance of the transmission of mathematical and astronomical knowledge that he was the instrument of. So many of his works were actually derived from Indian works, and he acknowledged this quite openly. Interestingly, his name, when his works were translated into Latin, his name AlKhawarizmi became AlKhawarizmi, and AlKhawarizmi is the origin of the word algorithm. And this is interesting because algorithm was one of the favorite Indian methods of calculations, both in mathematics and in astronomy. So one work was, for example, Zij al-Sindh. Zij is astronomy in Arabic, and this translates as astronomical tables of Sindh and Hind. And this is largely based on Indian trigonometry and Indian astronomical observations. He has also a book on Hindu-Arabic numerals. It survives only in a Latin translation, which is this Algoritmi de Numero Indorum in Latin, and which introduced this system to Europe. The system in Arabic was called Isab al-Hind. So therefore there was no concealment about the source of this knowledge. And in Europe, and I will close with this because this is the beginning of a whole different chapter. In Europe, two great figures, were instrumental in popularizing this work, which not only, I should say, did not stop at just numerals and the decimal system, but also a lot of procedures of algebra. Brahmagupta and his algebraic advances were also much discussed, like equation resolution, for example, by AlKhawarizmi. So Adelab of Bath is the first translator of AlKhawarizmi's works into Latin, and later on Fibonacci also was, and this is one page from his work where you see the Hindu, as they were called, numerals appearing here on the margin. So this is the beginning of a whole different period. In fact, a little later, in the 13th century, Aryabhatta was translated into Latin, and Aryabhatta was given the Latin name of Ardubarius. Of course, the translation was not from Sanskrit. It was through a lost Arabic or Persian translation. So Ardubarius was the Latin name of Aryabhatta. So this is the beginning of a whole different story, which is much better known. The controversies will continue sometimes, and at the end of the day, as I said, many of them remain open-ended and can be very fruitful fields of research. With due caution, it is not as if we are trying to prove that India was always the first or the foremost. It's certainly borrowed also, but it looks that on balance, in the field of science and medicine, on balance, it seems to me, as objectively as I can, that India gave much more than it absorbed from other cultures. Thank you very much. It's okay.
The 360-degree orbit, was referred to in the Tang Dynasty works or something, which came from India. But earlier you also said that the 60
Yes.
minute hour came from
True.
I'm saying these two seem to be linked, and so how?
Yes, it seems to be linked, but you see, the 360-degree has been sometimes said by some Western scholars to be of Babylonian origin, but it is not certain. The reason is that certain Indian lunar calendars, when normalized to 30 days, a lunar month of 30 days, there is one such system, then naturally come to 12 months of 30 days each, which is 360 days. So in that case, a system of 360 degrees is natural. So therefore, this 360 degree, I do not know if there is a final knowledge on it, but it could very well have emerged independently in India and in Mesopotamia. I do not know if we have any conclusive, migration, evidence of migration from one to the other.
queries about some statements, some information you have given. You have said about the dosha theory of Ayurveda and Plato's universe, which yoga has worked on that, with classical doctrines of Indian medicine and elsewhere. Being a student of Vedas, I find that there is no clear reference to Tridosha theory in Vedas or Brahmana, Upanishad or Vedantas. I feel that it did not exist, there is no textual evidence for this before 500 BC. And the first systematic mention as a doctrine of dosha theory occurs in Sushruta and Charaka around the beginning of Christian era. So it might, of course, it does mean that it has a long history. But then since we do not have any reference, we have something like Pitta and Vata, but we have common sense, not the dosha theory, so this is one. So what would you say about that?
Very briefly, Filiosa, who writes this paper, and I'll be happy to share it, I think it's in English. Filiosa, who writes this paper, does find some, I fully agree with your textual data, but he does find in Atharva some antecedents of the three doshas, though not explained as a system of three dosha. But he does trace some of them to Atharva, and he finds that the concepts are already there, but not explicitly built into a system. This is his argument. So you should like to go back to his detailed references.
Any other question?
Two. Vidya Deshpande's work on Chinese ophthalmology.
Yes.
She has translated them into English. Some recently it has been published in collaboration with some Chinese scholars.
Yes.
And I had browsed through that.
Good.
And I feel that these names, the works were ascribed to Nagarjuna, but they are not of Sanskrit origin. They must have been composed in China, and like Tibetans, they ascribe to personality.
That's quite possible. I'm not competent to decide on this. Yes, you may be right. But as you know, Nagarjuna was also a kind of a semi-mythical author, and many texts were ascribed to Nagarjuna, and we don't. Yes, and we ultimately cannot pinpoint the authorship.
And thirdly, in the whole your presentation, I missed a reference to a very interesting work, this Astronomy in Kala Chakra Tantra. Kala Chakra and Tibetan Calendar.
Yes.
By Edward Henning, where he has consulted also some Sanskrit sources.
True.
Kala Chakra information.
Yes.
So I would like to comment on that.
Very well. No, that reference would have to be included, I agree. But then there are so many other things which we would need to include. Yes, the whole question of calendars is a very complex and intricate, and I deliberately avoided it because, again, it's very difficult to decide. We, of course, know that all calendars were lunar and unisolar, but exactly which who culture adopted which system from whom is not easy to answer. So I avoided going into this field. Thank you.
So, just two questions. One is regarding the stars. I think the claim today is much more about the Mesopotamians using the star system as a tracking the celestial bodies. But initially it was thought that the Mesopotamian system was borrowed by Indians, but the current consensus in amongst the Western scholars is that they are independent.
Yes.
This one comment. The other one as regards Bia's finding the Aryabhatta slightly after 499. In India itself there are two sort of versions about Aryabhatta's time or Aryabhattiya's time.
Yes.
There are many Indian texts which attribute an important epoch to 522 CE. So this what is called the Shakabda correction, Vagbhavonat, etc. which Sharmaji has published in his Haridatta's work. So that refers to 522 CE as the time of Aryabhatta.
Yes.
So that might be closer.
Well, if you look very closely at his graph, and he writes, Roger Bia writes that his data points to 510. So I do not know if it matters very much 10 years this side or that side, but it happens to fall just in the middle.
Just a last one. Oh, you want to say, please? Still 2 minutes.
Yes, that one was it. You have presented about the possibility of practice on major transmission in the Indian science, pure science, Indian pure science and other concepts. But then India had a rich tradition also in architecture.
Ah, of course.
And metallurgy.
Very much.
Aspects.
Yes.
So, what do you do about it?
But that is a whole different field. That is a whole different field. Yes, architecture, of course. We can look at Southeast Asia and some parts of Central Asia, no doubt about it. The transmission was huge. But this is a little beyond my topic for today.
Sir, last comment in this suggestion. It's wonderful you have titled it cross-cultural interaction. Even in material interaction, the interaction is never one way. Even the processes of osmosis go both ways. That depending on the index, there may be a net transfer from one side to the other.
Absolutely.
So we can never claim that when there is an interaction that one is a complete borrower and another is a complete giver. It never happens. It always happens that something sort of peels off from one side and goes into the other.
Absolutely.
And as it's good that you have done all these French sources. And I remember you had started a wonderful project on translating French sources with the Indian Council for Historical Research. Unfortunately, perhaps it might not have moved at this pace at which it should have moved. But there are these 3-4 works which still need to be translated, I think. Cassini's work is in English, it has been done. But Jean-Sylvain Bailey's treatise on astronomy.
Yes.
Duchantil's accounts of Indian astronomy.
True.
And even our Roger Villard's work.
Yeah.
Because there is so much debate about it, but very few scholars in India who work on these subjects know French.
Yes.
And it's a great service that's sort of put in English the current scholarly language of Indians. Maybe we'll
So I think once the current 3 works, which are general works on the colonial era, are over, maybe we can retain our team. And I do not know whether ICHR would be willing, but this would be a very valuable project. Yes, there's a lot of pressure.